Just a few days ago, the worst nightmare of every open source maintainer finally came true. No, they weren't forced to socialize with the opposite sex. Instead, in just 6 minutes, which I've been arguing for years is actually quite a long time, over 100 packages that collectively get downloaded more than 50 million times a week were compromised in a supply chain attack where no one was phished, no passwords were leaked, and no tokens were stolen. And to make it even worse, the poisoned packages were signed, verified, and shipped through NPM's trusted publishing feature, which was built primarily to prevent these kinds of attacks and has been the recommended publishing setup for almost 2 years now. In today's video, we'll break down the clever trick that let an attacker hijack the release pipeline of one of the biggest projects in the React ecosystem. We'll see how the malware then spread to hundreds of other packages, and learn about the dead man switch, which is now on every infected machine that will nuke your home folder the second you try to clean it up. Heaven help us all. It is May 14th, 2026, and you're watching the Code Report. Life has been extra exciting lately because every time I wake up, I wonder which one is going to destroy my life first, the rodent poop cruise virus or the mini shai-hulud virus. Thankfully, I'm no poop expert, so I'll stick with breaking down how the shai-hulud prairie dogged its little head again in a fairly sophisticated attack that no one saw coming, and it all started with how Tanstack's release process works. Whenever a new pull request is merged, a GitHub Actions workflow kicks off, which handles publishing the new version to the NPM registry. But to do that, the continuous integration server needs to get a publish token from NPM first. To prove the request is legit, GitHub itself signs a statement saying which workflow is running, in which repo, and on which branch. NPM then checks that signed statement against the org's allow list and only hands over a token if everything matches. The token then lives for a few minutes in the CI's cache and then quickly becomes stale, so there's nothing for traditional phishing attacks to steal. This sounds bulletproof, but the problem is that the mini shai-hulud attack wasn't traditional. Here's how it worked. The attacker forked the Tanstack repo, created a pull request, and then immediately closed it. Even though it was just a fork and the pull request was never seen by anyone, just creating the PR was enough to kick off the publishing workflow. And this is where the Tanstack team went wrong, because when they configured the trigger for the workflow, they used the pull request target option, which meant that any pull request that came in would run in the context of the main repository, along with the main repository's permissions, even if the PR was created from a fork. Those permissions were enough to allow the attacker's code to write a poisoned file into the shared cache of the CI server, which is used by GitHub Actions to reuse dependencies between jobs. A few hours later, an unrelated pull request was merged into main, the poisoned file was triggered, which grabbed the NPM publish token from the cache and used it to take a massive shai-hulud dump on the 84 brand new compromised Tanstack packages. From there, if you were lucky enough to NPM install one of those packages, the malware ran and scanned your system for anything valuable it could get its grubby little sete on. And if it found any NPM publishing tokens, it used those to publish new poisoned versions with the same hack, which is how a Tanstack problem became an everybody problem. The first wave of victims included maintainers at Mistral AI, UiPath, OpenSearch, Guardrails AI, and Squawk. Within hours, those companies pushed compromised packages onto the NPM registry as well, and through their Python SDKs, the worm jumped the shark over to PyPy. By the next morning, security firm Akito was tracking 373 poisoned versions across 169 packages, and the worm was getting even smarter. It started forging commits signed by the Claude Code GitHub app, so its malicious activity blended in with the AI-generated commits maintainers were already used to seeing. And on infected machines, it embedded itself directly into Claude Code and VS Code, so even after a developer uninstalled the bad packages, the worm would just re-execute itself the next time they opened their editor. And my favorite part, if you were infected, the malware also installed a background process that would quietly check every 60 seconds whether your stolen GitHub token was still valid. The moment your token expires, it activates war crime mode and nukes your root directory. So how do we prevent this in the future? Well, the reality is that we probably don't, but there are some things you can do on your end to help your odds. The best would be to use PNPM 11 or higher, which comes with 2 features turned on by default that would have stopped this exact worm from reaching most of you. The first is minimum release age. It tells PNPM to refuse any packages published less than 24 hours ago, which is long past when most malicious packages are detected and pulled from the registry. The second is block exotic subdependencies. Normally, every transitive dependency in your project comes from the NPM registry, but there's nothing stopping a package from listing a dependency that points at a random Git repo or a tarball URL on some attacker's S3 bucket. Block exotic subdeps refuses to install anything that doesn't come through a proper registry, which closes one of the most elegant ways for malware to smuggle itself in. And the third PNPM feature worth using is approve builds. Most NPM malware does its damage through install scripts that run automatically when you type npm install. The PNPM 11 blocks all of them by default and lets you walk through your dependencies and whitelist the few packages you actually want to let run code. But even when using PNPM, things can still break in production, and that's where Sentry, today's sponsor, can help you out. They just shipped Seer Agent, an AI agent that investigates your production issues for you. So the next time you get a jump scare Slack notification about a bunch of new errors, you can just ask Seer Agent to investigate the problem instead of manually digging through dashboards and logs yourself. The agent uses all the context Sentry already has on your system to pull traces, spans, logs, and replays. Then it walks upstream across your services to find the actual root cause. From there, you can work with Seer to draft a fix and open a pull request, so you can spend less time staring at error messages and more time pretending to touch grass. The developers are calling it self-healing software, and you can try it out for free right now during the open beta at sentry.io/Fireship. This has been the Code Report. Thanks for watching, and I will see you in the next one.